Alrighty. So on this one, I'm going to define a couple of rules here for you. The first one we're going to define is going to be the zero power rule. Might not be what it's called if you looked it up elsewhere, but this is what we have defined it before. And the zero power rule says that if I have any variable or base raised to the zero power, I get 1. We had a discussion about this in class, and it was a discussion between, is it this or can I just take it away? Okay? And so the way that I'm going to show you this is we're going to mathematically perform this power rule and see how it works. We can't just say, oh, it's just gone. Because if I say that and then everything's raised to the zero power, what is your answer? See? We have people say 0, we have people that don't know what to write, and we have people that say 1. And so we're going to perform it mathematically and not just say, oh, when it's this, I can just take it away, because that doesn't last. Okay? And there's no defining to that, and there's no backing to that. Okay? And so up at the top, there's nothing that can be done, and the bottom there is. We have y to the 0 and z to the 0. And so if I define it with the zero power rule, it says that anything raised to the power of 0 equals 1. And so nothing happens in the top yet. And in the bottom, y to the 0 is 1. Z to the 0 is 1. And now I can multiply. Okay, and when I multiply, the top still has not changed yet because we haven't addressed anything up there yet. And the bottom becomes 4, or x to the negative 4 times 1, which is just 4 to the, x to the negative 4 becomes that. Okay? So the next rule that we're going to discuss is going to be called the quotient rule. Okay? And in the quotient rule, what word does quotient associated with? Division. Okay? And so division is unmultiplying something. Multiplication is repeated what? Addition. So if division is unmultiplying, then therefore unmultiplying is unadding, which is subtraction. And so that's going to help you know what you do inside this rule. I'm subtracting the exponents. It says that if I have x to the a over x to the b, and here's what I want you to get out of this fact right here, is that these are what we would like to call like bases, then what I do is I have x to the power of the numerator subtracted by the power of the denominator. So what I have to do from this point is I have to look for like bases. And the only one that I have is x. X is a like base. And so 3 doesn't change. This is going to be x to the third and x to the negative 4. What is 3 minus negative 4? Who is it? What did you say it was? Negative what? I want you to say it with some gusto.
Can you move the paper controls?
Yes, ma'am. I'm just putting it there for a second because that's where the bigger number is when looking at it. Okay, we'll talk about it in just a minute. Negative 7. Okay? Y didn't adjust to anything. Z didn't compare with anything. Last property that we're going to talk about in these, so that means that if these show up in the other two problems or the problems that I'm working, I don't have to define them anymore. Okay, we're just going to talk about them now. It's called the negative power rule. If you look this up, I would assume it would be called that, the inverse property. Okay, and what it says is if I have x raised to the negative a, where a is any power I want it to be, then what happens is it flips it and it becomes x to the positive of that power. Okay? And so what we have here is we have 3 negative powers, don't we? And so this negative 7 is going to go up there, and this y and z are both going to come to the bottom. We do the opposites of those. And so what I'm left with is 3x to the 7th over y to the positive 1, or just y, and x to the positive 1, or just x.
Coach Wells, that's supposed to be Z.
That's the answer?
Z, sorry. That's the answer. Thank you.